Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the quotient rule of derivatives. So as per the problem, a motorboat goes towards a dock with its engine off. Its distance s in meters from the dock, t seconds after the engine is turned off, is s at t equals 10 parentheses 6 minus t over 10 plus 3, where t is between 0 and 6 seconds. Now we have to find that how far is the boat from the dock initially and find the velocity of the boat when it bumps into the dock. Now we are given the domain of this function, this position function or the distance function as 0 to 6. That means at t equals 0, the engine is turned off, and at t equals 6, the boat reaches the dock. Now in part A, we have to find how far is the boat from the dock initially. That means in part A, we have to find the distance of the boat from the dock at t equals 0, because that's when the time recording starts. So we should sub in t as 0 in the given distance function. So s at 0 is equal to 10 parentheses 6 minus 0 over 0 plus 3. Now we can simplify this expression. So we get s at 0 equals 10 times 6 over 3. And we can simplify this expression too. So 10 times 6 is 60, and 60 divided by 3 is equal to 20. And the unit for distance in this problem is meters. So this should be the final answer for part A, that the boat is 20 meters from the dock initially. Now in part B, we have to find the velocity of the boat when it bumps into the dock. Now the boat will bump into the dock at t equals 6 seconds because that's the upper end of the domain. Now we are given the distance function, and we know the velocity function is the derivative of the position or the distance function. So the first step is to find the derivative of this given function s at t. Now this function is a rational function, so we'll use the quotient rule to find the derivative of this function. So our first step will be b at t is equal to prime of s at t. Now since 10 is a constant, we can keep the 10 at the front, and we can find the derivative of 6 minus t over t plus 3 using the quotient rule. So we start with the derivative of the numerator, which will be 0 minus 1 times the denominator t plus 3 minus the numerator 6 minus t times the derivative of the denominator 1 plus 0 over the square of the denominator, so t plus 3 square. Now we can simplify this expression. So we have t equals 10, and in the parentheses, so 0 minus 1 is negative 1. So we do negative 1 times t plus 3. And in the second part, 1 plus 0 is just 1, and multiplication by 1 won't change anything. So just 6 minus t in parentheses over t plus 3 squared. Now we can simplify the numerator by distributing the terms. So in the first part, we can distribute negative 1 into the parentheses. So we get negative t minus 3. And in the second part also, we can distribute the negative sign in the parentheses. and then change the sign of the terms in the parentheses. So we get negative 6 plus t over t plus 3 squared. Now we can combine like terms in the numerator. So negative t and positive t cancel each other out. So we get v at t equals 10. And in the numerator, we get negative 9 over t plus 3 squared. Now we have to find the velocity of the boat when it bumps into the dock, and that happens at 6 seconds because that's the upper end of the domain. So we have to sub in t as 6 in this velocity function. So v at 6 equals 10, and then parentheses negative 9 over 6 plus t squared. Now we have to simplify this expression. So 10, and then in the denominator, we get 6 plus 3, which is 9, so we get 9 squared. Now we can simplify the fraction by cancelling out 1 over 9. So we get 10 parentheses negative 1 over 9. Now we have to multiply the terms. So v at 6 is equal to negative 10 over 9. And the unit of velocity is meters per second. So this should be the final answer for the velocity of the boat when it bumps into the dock. So we get a negative answer here. Now velocity is a vector quantity, so it can be a negative number. So these are the steps you have to keep in mind to solve this type of problem. So it's very important to understand that since the given domain for the position function is from 0 to 6 seconds, that means 0 is the time when the engine is turned off, and at 6 seconds the boat reaches the dock. So that's why we're finding the velocity at 6 seconds. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.